Hey everybody, this is Seth. This is my video review problem. I chose something from an earlier chapter because as I was looking through everybody's choices, it seemed to be more of the later chapters, so I kind of recover some of our earlier knowledge and information. What I chose to do is I chose a problem from the textbook section 11.5, and this is going to be, that section is called Lines and Planes in Space. This problem, number 49, covers a couple things, so it's more than just finding the equation of a plane using 3 points. We're also going to cover a couple different things. We'll cover standard form of an equation plane, general form, scalar multiples, cross product review, a couple different things. So starting with this, just pretty basic review. We're going to give our points here some arbitrary values. We could just pick some letters A, B, C. We could choose something else, but we'll stick with A, B, and C for right now. So let's just rewrite those out next to the side. Like these problems, I just like to write everything out and keep everything organized in some sort of fashion because they can be somewhat, not incredibly long problems, but long enough where you can make mistakes. So I've called these points A, B, and C. What we're thinking here, the points should be on a plane, so if I was to draw a plane off to the side, let's just say this is the above view of a plane, we should have points here, I don't know, somewhere over there. Doesn't matter for right now, just a visual. Let's say that was point A, B, and C. What we can do with these points and what we can do with this information, just basic review, we can create some vectors, A, B, and AC. And what we can do from that useful information, we're going to find the cross product of those two vectors. And that's going to give us a normal vector, which would be my pen here. I doubt I can get it to stand up, but let's say it was that big. That would be our normal vector, which is oddly enough going to be our the same a part of our tangent plane equation, the A, B, and C values. Okay, so let's turn our points here. Let's turn those into some vectors. We'll go vector AB is going to be equal to, now I like to write these out just the long way once again and just make sure I'm not making any mistakes. I'll go terminal point minus the initial point. It seems like more work and it's probably going to make this video longer and make you a little bored watching it because it's basic, but I think it'll be worth it. So vector AB is going to be equal to 2, 0, negative 2. And we'll squeeze AC in here over to the side just to save room. Negative 1 minus 1. Negative 2 minus 2. Squeezing in here. 2 minus 3. Cleaning it up and writing it bigger so you can hopefully see it. Okay, so now we have our two vectors, AB, AC. Let's take those and let's find the cross product of those. Just a quick cross product review. Now normally what I would have done, I normally write vectors AB and AC right underneath each other. So my cap would represent AC in this point. I write them right underneath each other just so that I can create my I, J, and K columns so that I can do the cross product more quickly and efficiently. But just for the sake of this video, we'll rewrite them out below here. So we're going to have vector AB, AC. We'll have our I, J, and K values for both, which we can use in our cross product. And now let's look at it this way. This would be our I column, our J, and our K. Now for the cross product, we'll write this out in full. I found that this is where I messed up a lot of stuff with the cross product. For some reason, I would just create values that just didn't exist or multiply 0 times something and get something other than 0. So I like to just kind of keep it simple. I like to keep different style brackets just so I can multiply everything out here. It's just something that worked for me in the past, and I recommend it. I believe on the web work, I would just print them out, write them out like this, and just take up a full line and squeeze it onto one page, but you know, it works for me, so hopefully that's something that could work for you. We have our I value, our cross product. It's almost like cross multiplying if you think about it when you're covering one up. 0 times -1, -2 times 4. Slide it over. I think a big thing that some people will mess up is that minus instead of a plus. It's going to be I minus j plus k. So writing this out some more, 2 times -1 minus -2 times -2. That's our j. Plus, slide our cap over to cover up the k column. 2 times -4 minus, now this is 0 anyways, but I like to write it out. Squeeze it in there, k. Okay. This should fit a little bit easier on the page here. I get 0 minus 8i minus -2 minus 4j plus -8 minus 0. Okay, and finally, now this cross product has given us, remember, a normal vector at that point, which is also going to be the a, b, and c values of our tangent plane equation. So this is going to be -8i plus, we have a negative minus 6, double negative, positive 6j minus 8k. Now we can also rewrite this as our normal vector is going to be equal to -8, 6, -8. Okay, now we can work with this. We're going to get a new sheet of paper here. I'm going to slide this up a little bit. Hopefully it stays on my page here. Next sheet. Okay, now we're going to plug this into our tangent plane equation. Now if you remember our tangent plane equation, we're going to be equal, it's going to be equal to this. Our a value times x minus an x value of a point on the plane. Same thing for the b, a y value of a point on the plane. Sorry, that's a plus z minus a z value. Okay, now we just plug in our a, b, and c. If I was going to write this a, just so you can see it a little better, that's going to be our a, our b, and our c. And I'm also actually just going to pick a point that was already given to us. We could go ahead and we could find a point on one of the vectors from before. We could go ahead and find a point somewhere on here if we needed to, because that should also be on the plane if it's on the vector. But why do that when we already know the endpoints? It's already given to us, so we'll just simply steal one of those points, and I'll steal, let's go with the first one. We'll go with point A. Now, I probably should have chosen some slightly different values, and then this is why they're kind of arbitrary values, or I'm sorry, variable or number, or whatever you want to call them, for my points, because now I have an A and A. That could be a source of confusion. You could think of something else, go with your initials, or go with something that's not going to be in the problem, anything such as that. So let's just quickly go through this. We'll break these in, or we'll substitute these in. Go x minus 1 plus 6 times y minus 2 minus 8 times z minus 3. Just distributing out our values. Oops, you know what? I messed that part up. I'll skip that part. Sorry about that. Negative 8x plus 8 plus 6y minus 12 minus 8z plus 24. And just a little even simpler than that. Now we'll go and just clean it up and we'll be practically done here. We only have one more step after that. We'll get negative 8x plus 6y minus 8z plus 20. Now, what we want to do to get a tangent plane equation, we need z alone by itself. We're going with z equals some x, y function. So we'll just add 8z to this side. And plus, oh my gosh, sorry, rewrote that twice. 8z minus 8 minus 8x plus 6y plus 20 divided by 8, we'll end up with our tangent plane equation of negative x plus 3/4 y plus 5 over 2. This is our tangent plane equation. Just a quick check of something here. We'll just label it right here as our check. You can take any of the other points. We'll take point B, which was 3, 2, 1. We should be able to substitute it into that equation and get it should be equal to each other. So let's try that. We'll go 1 is equal to negative 3 plus 3/4 y value times 2 plus 5 over 2. A little more simply, equals negative 3 plus, quick math there, 8 over 2, which is 4, so 1 is equal to negative 3 plus 4. 1 is equal to 1. It checks. That should be our equation. Now we're going to plug that into the applet. Sorry for my couple mistakes there. But we're going to plug it into the applet and we're going to see what happens.